So for our second example, the processors of fries ketchup indicate on the label that the bottle contains 16 ounces of ketchup. The standard deviation of the process is 0.5 ounces. A sample of 36 bottles from last hour's production revealed a mean weight of 16.12 ounces per bottle. At the 0.05 significance level or 95% level of confidence, is the process out of control? That is, can we conclude that the mean amount per bottle is different from 16 ounces? And here we have the hypothesized mean as 16 because it is our claim, or it is the company's claim, that their bottle contains 16 ounces of ketchup. So we have to state the null and alternative hypothesis. To guide us in stating the null and alternative hypotheses, we have this. So hypothesis test for population mean. The sample size must be greater than or equal to 30. Population need not to be normally distributed. Sample will be approximately normal. So it is always the case that in stating the null hypothesis, we equate the true mean to the hypothesized mean. Okay? The only difference between these hypothesis testing is its alternative hypothesis. There are some cases that the alternative hypothesis states that the mean or the true mean is not equal to the hypothesized mean, or it is greater than or less than the hypothesized mean. Now, since in our example, it asks us to determine, or it asks us if can we reject the claim, or can we say that the mean weight is or differs from 16. Hence, we are just going to use not equal because it does not involve less than, greater than, or shall I say better or less in its or as its comparison. So for here, we have the alternative hypothesis as this one. Okay, the null hypothesis is always mu is equal to the hypothesized mean, in this case 16, and the alternative hypothesis is, in this case, mu is not equal to 16. Now, we are to state or specify the level of significance alpha, sample size n, sample mean, and population or sample standard deviation. We all know that the alpha is 0.05, sample size is 36, sample mean is 16.12, and the standard deviation or population standard deviation is 0.5. And we are to choose our test statistic. Okay, we are going to use this one, okay, the known variance, z-test for known variance, because we know, or it is, the variance is given. And now we have here for step number 4 is to determine the critical region and state the decision rule. And now let us recall this portion. If our alternative hypothesis is the true mean is not equal to the hypothesized mean, therefore our decision rule is to reject the null hypothesis if the absolute value of computed z is greater than or equal to the critical value of z. Okay, we are going to use the sigma instead of s. Okay, use sigma if it is known. Let us recall this one. Okay, since we have a two-tailed test and our level of significance is 0.05, tells us that the critical value is 1.96. Okay, for our decision rule, we are going to reject the null hypothesis if z, or the absolute value of computed z, is greater than or equal to 1.96. And we are not to reject the null hypothesis if the absolute value of computed z is less than 1.96. To give you further illustration on what we have, the rejection region is on the two sides. Okay? The rejection region is anything greater than 1.96, the pink one, and anything greater than, or less than rather, negative 1.96. And the non-rejection region is the white portion. So let us compute the test statistic. Again, what is the sample mean? Do you still remember? If I'm not mistaken, that is 16.12 minus the hypothesized mean, which is 16, all over 0.5, which is the population standard deviation divided by the square root of the sample size, which is 36. Again, all we need to do is to input this on our calculator and it will give us 1.44 as the value of z. Now, let us locate 1.44. Where is 1.44? We can locate it here. And obviously, it is in the white portion or the non-rejection region. It is here. Okay? Now, since 1.44 or the computed value of z, it falls on the non-rejection region, okay, what do you think will be, or what are we going to do with the null hypothesis? Is it rejected or not rejected? Okay, let us recall this one. Determine the critical region and state the decision rule on step number 4. We are going to reject the null hypothesis if the absolute value of z is greater than or equal to 1.96. And if not, we are not to reject. So, meaning, since the absolute value of z, which is 1.44, is less than 1.96, the null hypothesis is not rejected. And if we're going to recall the illustration, 1.44 falls under the non-rejection region, and it supports our decision rule that we are not to reject the null hypothesis. Okay, meaning there is no sufficient evidence to claim that there is a difference. Okay, there is no sufficient evidence to reject the claim that the true mean is equal to 16. Or shall I say, it implies that there is no sufficient evidence to reject the claim that the mean amount per bottle is 16 ohms.